This is the 6.3 practice answers. Number one, 11% of students at a large high school are left-handed. A teacher selects a random sample of 100 students in the school and records X, the number of students that are left-handed. Okay, so the mean and the standard deviation, what should I expect? So the mean of all of my sampling distribution, right? So if I take 100 students and another 100 students and another 100 students, find the mean every time, or the number, I would expect to have n times p, which would be those 100 students, and it says 11% are left-handed. So I would expect 11 students to be left-handed. Standard deviation of my sampling distribution, square root of n times p times 1 minus p. So it's the square root of 100 students in my sample times my 11% that I expect to be, and 1 minus the 11%. Okay, grab my calculator. And I get a standard deviation of 3.13. Okay, so it says to interpret the standard deviation from part A. Okay, we would say the number of left-handers would vary from the mean of 11 by about 3.13 people. Okay, the second question says, would it be appropriate to use a normal distribution to model this? Okay, so for something to be approximately normal, where n times p and our n times 1 minus p, they both have to be greater than or equal to 10. Okay, so in this case, our n times p was 100 times 0.11, which was 11 people, and our n times 1 minus p was 100 times 1 minus 0.11, which was 89 people. So both are greater than 10. Therefore, yes, we could say the distribution is approximately normal. Okay, third question. Calculate the probability that at least 15 of the members are left-handed. So with the probability that my x, at least 15, would be 15 or more, greater than or equal to 15. Okay, so we know that it is approximately normal from number 2. From number 1, we know that our mean is 11. It has a standard deviation of 3.13, and I want to know the probability of 15 or more. Okay, so you go to Desmos to find that answer. Okay, it's the same thing as we did last chapter. You go to normal dist in your Desmos, put in your mean and your standard deviation, click the box for cumulative. Our minimum is 15 and our maximum is infinity. And we get an answer that was about 10%. Okay, so there's a probability of 10% of the time getting 15 or more left-handers in our sample of 100. Okay, number 4. In the United States, 20% of adults aged 25 and older have never been married, more than double the figure recorded for 1960. If we select a random sample of 50 adults aged 25 and older, and Y is a number who have never been married. So we're selecting 50 people, and we know that 20% of them have never been married or suspected. Okay, the mean of our x bar is our n times our p. So we're taking a sample of 50 people. We expect 20% of the people to not have been married. So 50 times 0.2 gives you 10 people. We would expect 10 people. Okay, with a standard deviation square root of n times p times 1 minus p, which would be the square root of 50 times p times 1 minus p. And that would be 2.83 people. Okay, interpret the standard deviation. The number who have never been married would vary from the mean of 10 by about 2.83 people. Okay. Number 5, is it okay to say that it's approximately normal? Okay. So we know that n times p and n times 1 minus p, we got to find those. Both have to be greater than 10. We found n times p to be 10 people. And n times 1 minus p would be 40 people. So both are greater than or equal to 10. We're close there, but it's equal to. So therefore, we can say that it is approximately normal. Okay, so number 6, we want to find what's the probability that at most 5 individuals have never been married. The probability at most 5 would be 5 or less. It's less than or equal to 5. Okay, so we know that it's approximately normal from part B, from number 5. We know our mean from number 4 is 10. It has a standard deviation of 2.83. And we want at most 5. So 5 or less is what we're trying to find here. Okay, so go to the normal distribution again and put in your mean and your standard deviation. We go from -infinity to 5. Okay, our answer comes up to be 0.039. Okay, next one, number 7 for you. About 10% of the people in the U.S. have type B blood. Suppose we take a random sample of 120 people. X is the number of people who have type B blood. Mean is n times p, which would be 120 people times 10% would be, we would expect 12 people. Standard deviation, square root of n times p times 1 minus p. Gives us 3.29. Okay. Interpret the standard deviation. The number with type B blood would vary from the mean of 12 by about 3.29 people. And this is, as hopefully you realize, out of 120, right? If I'm taking a sample of 120, the average number of people would be 12, typically varying by that. Okay, part B, I know it's approximately normal because n times p and n times 1 minus p. So we 120 times 0.10, which we had as 12 people with, and we would expect 108 people without. Therefore, both greater than or equal to 10, therefore approximately normal. And then part C, 16 or more individuals, what's the probability that it's 16 or more, greater than or equal to 16? Okay, we know that is a mean of 12, standard deviation of 3.29, 16 or more. Okay, you're going to go to Desmos and get it. And 16 or more there comes up to be about probability of about 11%. And the very last problem for us, U.S. quarters. According to the U.S. Mint, 54% of the quarters that were minted in 2014 were produced by the Denver, Colorado Mint. The rest were in Philadelphia. There's two different places where coins are made. I visited both of them, so they're pretty interesting places. Anyway, in a random sample of 200 quarters, what's the probability of at least this many? Okay, so we have to go through the process here, right? The mean I would expect in my sampling distribution of 200 quarters would be n times p would be 200 quarters, and 54% would be 108 of them. The standard deviation, n times square root of n times p times 1 minus p, be 200. Well, you can't see that. Okay, 200 quarters times the probability times 1 minus the probability gives you standard deviation of 7.05. Okay, I know that n times p, the first step. Second step, is it approximately normal? Okay, so n times p I know is 108. Oh, I can write that. And 200 times 1 minus 0.54 gives me 92. So both greater than or equal to 10, therefore approximately normal. Okay, third step, find that. We know that it's approximately normal. We know the mean is 108 with a standard deviation of 7.05. And we want to find the probability that they are at least 115 of them. So we want 115 or more out of the 200 coins. So x is greater than or equal to 115. Go to Desmos, and I get 0.16 from Desmos. Okay, so come to class ready for any questions.